Hi guys, welcome to the second lecture of circuit theory. So I hope you all have been revised to the basics. Just go through all our theories once, like how to apply nodal, how to apply mesh analysis. It's better to know if you revise all those things that will be helpful for you while solving the problem. As I told you, in circuit theory you no need to memorize anything. But the thing is, while solving the problem, your mind will get habituated with some trickies that you have to decide. Like what kind of trickies I'm telling. We have learned so many methods, right, in circuit theory. See, ஒரு கொஷினை சால்வ் பண்ணுறதுக்கு இந்த மெத்தடை தான் அப்ளை பண்ணோம் அப்படிங்கிறது எதுவுமே கிடையாது. நம்ம லேர்ன் பண்ண எல்லா மெத்தடுமே வந்து டு சால்வ் a single question only. அதில் depends on the position, அந்த இடத்தை பொறுத்த depends on the nature of the question. We have to decide which method is the best suitable method to bring the answer in a shortest time. Okay, that for that some basics are required. I hope you all have been revised the basics. So let us start up with the first question. So in circuit theory, I am just going to draw the questions here, and you are just supposed to bring the answer by your own way. Just apply your common sense. All are small questions only. Let us start up with the first question. So here the question number 1 is, so let me take a circuit, and here we are having a battery voltage. With this, there are three resistors which are connected in parallel. So let me draw the circuit first, so you can just follow me. And as I told you, once you get the complete clarity about the question, try to bring the answer by yourself, because questions are very easy. Now here, they told that the value of this battery voltage is simply they kept V. They have not given any voltage, that it is considered as V. Next, what they have done is, here they kept the value of resistance as 2R. This resistance they kept as 4R. This resistance they simply kept as 6R. Now the question is, the current taken by this first resistor is I1, current taken by the second resistor is I2, current taken by the third resistor is simply I3. So what must be the question now? You know what will be the question? The question is ratio between I1, I2, I3 is dash. That is the question. Okay. So what can we do? How to bring the answer? Nothing is there. Just you have to bring the relation between I1, I2, I3. I hope you might have some basic idea how to do this question, because it is very simple question, right? Yes, sir. So let me write. See, what I am going to do is, see, I am repeating again. Circuit theory lectures there is no point of letting expecting answer from my end. அதுக்கப்புறம் நீங்க சொல்யூஷன் போட்டு அது என்னோட சொல்யூஷனோட கம்பேர் பண்றதுக்குலாம் இங்க வேலையே கிடையாது. You all are supposed to go up with your own method. You can apply whatever the logic that you are getting, that is generated from your brain. So here in the instantல எனக்கு என்ன method தோணுதோ, I'm just going to apply that method. So you are supposed to apply your own method. Okay, fine, sir. Suppose if you are not getting any idea, then you can see what I am trying to do here. So here simply what I am doing is, what my mind is doing here is, எனக்கு என்ன தோணுதுன்னா, see, since all these three branches are connected in parallel with the supply voltage, yes, the question is, we are requested to bring the relation between I1 and I1, I2, I3. அப்ப இவங்க எல்லாருக்கும் வந்து நம்ம ரிலேஷன் கொண்டு வரணும் அப்படின்னா, I1, I2, I3 வந்து directly we can write in terms of voltage V. See, in parallel circuit, the applied voltage will be remain same in all branches. If it is V, same voltage will appear here. Same voltage will appear here also. Same voltage will appear here also. So you just tell me, what can we do now? Expression I1 can be written as supply voltage V divided by correspondent resistance. Yes or no? How will you write the current through this branch? I is equal to V by R. We know voltage drop across the resistor is V and the value of the resistor is R. Similarly, if you go for I2, voltage V divided by resistance 4R. Similarly, if you go for current I3, how can you write? The value of current I3 can be written as voltage V divided by resistance 2R. That's all. It's all right. Now the question is we have to bring the ratio between I1, I2, I3. It's over. So the value of if you take the ratio between I1 versus I2 versus I3, what will you obtain? It's very simple logic, right? I'm just taking, see, if I will take the ratio between I1 and I2, what I will get? But basically what I will get is the relation will give us the value of this is V divided by 6R divided by the value of I2 is V divided by 4R, such that the value of 4R will lies in the numerator, 6R will lies in the numerator. Of course R, V all are getting cancelled out. So we can say it will be 2 by 3. So the ratio between I1 versus I2 is 2 by 3. Now, chalo, let me do the same thing for I2 versus I3. What will you obtain? If you go I2 versus I3, then you will get the value of I2 is V by 4R. Yes, and the value of I3 is V by 2R. So this can be simply written as 2 by 4, or we can write this one as 1 by 2. But what my suggestion is, I will take 2 by 4 alone in order to bring the relation between these all people. Okay, such that we can match up them in a easiest way, or you can take 1 by 2 also, nothing is there, right? Such that I can write like this. See, the ratio between I1 by I2, how I can write is 2 by 3 is to 1, or you can also take it as 2 is to 3, nothing is there, right? So I am just considering here the common factor as 1, such that here also I can take this same common factor. That's why I'm writing in this manner. If you want to write this now, what you have understood, 2 is to 3 is to 2, if you want to bring the relation. But what is the missing factor? Here we have to bring the common factor between I2, right? So in order to bring the common factor, what can we do? We have to take, I'm taking the common factor as 1 here, so I'm just writing in terms of 1. If I'll write that in terms of 1, then it can be written as 2 by 3 is to 1 is to 2. So that is how we are bringing the relation between I1, I2, I3. I hope you all have understand the logic. So this is very simple question. Just we have to take the ratio between these three people. That's all. It's over. Right? Or otherwise directly you can write this. If you take the ratio, then 1 by 6 is to 1 by 4 is to 1 by 2. But after cancelling this common factors, I am writing in this manner. Okay, na? Okay, so let us go ahead with the second question. This is all about first question. Now, the second question is, let me take, I'm starting with the first resistor. Next, this is second branch. So I'm taking this is second branch, and then this has been again broken into two branches. This has been again broken into two of these two branches. This is gate question only. I hope many of you might see this question seen already, right? So like this here also again they have broken it. It is broken. It is broken. It is broken. Again here we kept two branches. Now after this all these resistors are connected together. Then this point is connected with a supply voltage. So that voltage, let me consider 10 voltage, and here this interconnected point has been treated as a return path. That's all. This is the given question. Now what you all are supposed to do is consider all the resistance value as 2 ohm, 2 ohm, 2 ohm, 2 ohm, 2 ohm, 2, 2, similarly 2 ohm, 2 ohm, 2 ohm, 2 ohm. For all the resistor, they are given the value of resistance is 2. Now the question is, What is the current supplied by the source? That is the question. Current supplied by the source is what? That is the first question. And the second question is, let me take this one as I1. And what is the current through this 2 ohm resistor I2? Just they have been asked us to calculate the value of I1 and I2. That is the question. How will you do that? You have to, as I told you, right? You can go with your own logic. Whatever the things that you are getting, you can just apply that logic here. Fine, sir. So here what I am going to do is, my mind is tricking with this parallel concept. See, these 2 ohm resistor are connected in parallel. So if you reduce this, you will get 1 ohm resistor. Similarly, these 2 ohm resistor are connected in parallel. So if I will reduce this, again I will get 1 ohm. Similarly, this combination will give 1 ohm. This combination will give 1 ohm. So in resultant, what will happen? This 2 ohm resistor and here 1 ohm resistor are connected in series. This 2 ohm resistor, here this 1 ohm resistor are connected in series. This 2 ohm resistor and here the 1 ohm resistor are connected in series. Again this 2 ohm resistor, here this 1 ohm resistor are connected in series. So totally what we can see is the net resistance in this branch is 3 ohm. So how I can draw this? For your understanding, let me redraw the circuit. This resistor, I'm starting from here and then we are breaking it into two off. Here I have a resistor and here we have one more resistor. Now here the combined resistance value is 3 ohm. The combined resistance value is 3 ohm. Here also the combined resistance value is 3 ohm. Combined resistance value is 3 ohm. Again, if I'm just simply closing this, then we can treat this one as the our new circuit. Yes, sir. And what is the value of resistor? Here we have 3 ohm now. This is also having 3 ohm. This is also having 3 ohm and this one also having 3 ohm. And this one is having 2 ohm and this one is having 2 ohm. Here also we have 2 ohm. Supply voltage they clearly told they kept 10 voltage. Now the question is we have to find the current I2 and the value of current I1. Fine, sir. Again, I know your mind is freaking out with these two parallel branch. Sir, if I will reduce this again, I will get 1.5 ohm. Exactly, you are correct. Again, if you reduce this, you will get one more 1.5 ohm. There is no doubts. Yes, 3 means half of this resistor, 1.5. That 155 ohm resistor connected in series with this 2 ohm resistor. Exactly. So what is the value? It will become 2 plus 1.5 will become 3.5 ohm. Again here also 3.5 ohm. If you redraw the circuit again, then what you will get? I am having 2 ohm resistor here. Let us break. So here the net resistance here we have 3.5 ohm. And here the net resistance we have 3.5 ohm. So we have reduced the circuit as much as possible. Still you can reduce, but let me teach you. Do you remember the question? They are talking about this current I2 and the current I1 here. So this is 2 ohm resistor. Now our target is we have to achieve this current I2 and we have to achieve this I1. So you just remember this circuit as of now, and but I am going to reduce this circuit further. Now again what you have to think, sir, this 3.5 ohm, this 3.5 ohm both are connected in parallel. If you reduce this, again it will become half of this 3.5. Yes or no? Yes, sir. I hope it will be 1.85. So let me reduce. So finally what will happen is this 2 ohm and here if you reduce this two parallel circuit 3.5 both are connected in parallel, so the net value will become 3.5 divided by 2. If you cancel it, it will become 1.75, right? Yes, 1.75 only, not 1.85. So that is 1.75 ohm. Here we have 2 ohm and the value of the battery voltage source is how much? This is 10 voltage. Now the question is, from here what is the total current supplied by the source? Sir, whenever you are trying to find out the total current supplied by the source, what is the logic? If you want to know the total current supplied by the source, we have to do total voltage divided by total load. That is the basic. Total voltage is 10. Total load is how much? Now, we have almost reduced the circuit into final part. From the source, I can say this 2 ohm resistor and 1.75 both are connected in series. So, the total resistance offered by the circuit is 3.75 ohm. Take your calcium and reduce this, you will get the answer for this I1. Once you got this I1, then little bit again expand the circuit, redraw like this. இந்த மாதிரி வரைஞ்சிட்டு again என்ன பண்றீங்கன்னா, you got the value of I1 now. Yes, from here we are getting the value of I1. Substitute that value here, then we know, see, this 3.5 ohm, this 3.5 ohm both are connected in parallel. This I1 will come here after reaching this point. What will happen? Exactly, I1 will be divided into 2 off. Exactly it will divided. Correct, பாதி பாதியா break ஆகும். Why sir? Why? Because the parallelly connected loads are having equal value. When the parallelly connected loads are having equal value, then automatically the current that we are injecting will get divided into 2 off. So the value of I2 is what? I1 இங்க வந்ததுக்கு அப்புறம் என்ன ஆகும் அப்படின்னா, I1 வந்து 2 parts ஆ divide ஆகும். I1 by 2, I1 by 2. அதுல ஒரு I1 by 2 இந்த 3.5 வழியாகவும், இன்னொரு I1 by 2 இந்த 3.5 வழியாகவும் flow ஆகும். So what I can say, the value of I2 simply equal to I1 by 2. That's all. So this is how we are solving this question in a beautiful manner. This is the idea that I got, but as I told you, you just go with your own methods, whatever the methods that you are getting. Okay, but what you must do is you have to apply some simple tricks. You know all the basics. Always try to go from the fundamental basic. Like see, நம்ம இப்ப சர்க்யூட் தெரியல, நீங்க எல்லாத்தையும் எப்படி கத்துக்கிட்டு இருப்பீங்க? ஃபர்ஸ்ட் வந்து you will start from the basics of resistor, inductor, capacitor. அவங்க சீரியஸ்ல இருந்தா எப்படி ரிடக்ஷன் பண்றது, parallel இருந்தாங்கன்னா எப்படி ரிடக்ஷன் பண்றது, ஸ்டார் டெல்டா ஃபார்ம்ல இருந்தா எப்படி ரிடக்ஷன் பண்றது, and source transformation technique. These are all the basics that you have learned. With this you might have learned about, and then KCL படிச்சிருப்பீங்க, and then KVL படிச்சிருப்பீங்க. Slowly you might have learned about voltage division rule, current division rule. It will be slowly expanded, right? அதுக்கப்புறம் என்ன படிச்சிருப்பீங்க? You might have learn about nodal analysis. Then you might have learned about mesh analysis. After that only we are entering into theorem like Norton theorem, superposition theorem, Thevenin's theorem. Sorry, one minute. So then only இதெல்லாம் முடிச்சதுக்கு அப்புறம் தான் you might be enter into DC theorems and AC theorems also. So what my suggestion is, first try to go along with the basics while solving any question. Suppose if you are not able to solve with the help of basics, then you can apply the theorem that you want, that you are expecting here, right? I hope you understand the logic behind of this question. So let us go ahead with the third question. Okay. Now, what is the third question? The third question, what they have done is, let me draw the circuit first. Here I am having a resistor. Here I am having one more resistor. Here I am having one more resistor. Here I am having one more resistor. Totally 4 resistors are connected in series. First conclusion. Next, what happened is, they have connected this total resistive circuit with a supply voltage. Okay, so this is the point where we are going to connect the supply voltage. What is the amount of voltage that they have connected here? Nothing. They have simply connected 230 voltage. Okay, sir. Next, what they have done is, they had given the polarity, this is plus and this is minus, and I am just closing it for your understanding. Okay, so they told everything is they given. Then they told this value of resistance is 20 ohm and this is 30 ohm. This value is going to be 40 ohm and this value is going to be 10 ohm. Now the question is simply, they taken this circuit. Simply, they are going to connect one voltmeter here. One voltmeter is simply connected here. Now the question is, they are trying to disconnect the 40 ohm resistor from the circuit. 40 ohm resistor is disconnected or removed from the circuit. Resistor is removed from the circuit. Then what is the reading of the voltmeter? Then what is the reading of voltmeter V? That is the question. I hope you all have understand the question. See, where is the 40 ohm resistor? This is the location of 40 ohm resistor. வோல்ட்மீட்டர் கனெக்ட் பண்ண உடனே என்ன பண்றாங்க அப்படின்னா இந்த ரெசிஸ்டருக்கு எத்தனை டெர்மினல் இருக்கு? 2 டெர்மினல்ஸ் இருக்கு. இந்த 2 டெர்மினல்ஸை வந்து டிஸ்கனெக்ட் பண்ணிட்டாங்க. They have removed. After removing this 40 ohm resistor, what is the reading of this voltmeter? Can anyone tell me the answer? I don't think that you guys are expecting the options from my side. You have to give the answer because this is very small question. So let me tell you, actually what happen is when the moment you have to apply, you have to work too smartly because always the questions are very easy. Sir, when the moment you are removing this 40 ohm resistor, immediately if you redraw the circuit, what will happen? Let me show you now. Let me tell you. The 30 ohm resistor, see, I am just starting from 20 ohm, 30 ohm. Next, what happened? This portion is disconnected now. So it became open circuit. Yes, it is becoming open circuit, and this is the point where we are keeping our voltage. So I'm just closing this circuit, and here they kept 230 voltage, and this is the point where we are going to connect our voltmeter V. Okay, tell me what is the answer now. Irrespective of other value, it may be 20 ohm or it may be 30 ohm or it may be 10 ohm, it doesn't matter here. What happened? Sir, when the moment you are removing this, we know internal resistance offered by the voltmeter. Internal resistance offered by the voltmeter is very high. நம்ம கொஸ்டின்ல அவங்க என்ன சொல்லல அப்படின்னா வோல்ட்மீட்டர் வந்து ஐடியல் வோல்ட்மீட்டரா இல்ல பிராக்டிகல் வோல்ட்மீட்டரான்னு சொல்லல. So by default, questionல voltmeter பத்தி எதுவுமே பேசல அப்படின்னா whenever they are talking about voltmeter, if they simply tell that there is one voltmeter, then you have to treat that voltmeter is ideal one. That voltmeter will be treated as the ideal voltmeter. What is the meaning of ideal voltmeter? Ideal voltmeter will have the internal resistance as infinity. So by default, you can apply this logic. Don't forget because this is simple logic only. Practical voltmeter இருந்தா அவங்களே மென்ஷன் பண்ணிருப்பாங்க. Suppose if they want to play with the question, then they will tell the given voltmeter internally having this much of resistance. Like that they will tell. So you don't need to be bothered about it. So the internal resistance offered by the voltmeter is infinity. Then tell me what is the current consumed by the voltmeter? The current through the voltmeter is voltage offered by the voltmeter divided by internal resistance offered by the voltmeter. So what will happen? Maybe you can obtain some voltage drop across this internal resistance of the voltmeter, but resistance value is infinity. 1 by infinity will become 0 ampere. So current consumed by the ideal voltmeter is 0 ampere. Now tell me, in this open circuit, do you have any current? No sir, this is also 0. Because open circuit also, what is the meaning of open circuit? By default, the meaning of open circuit is telling that the resistance at that point is approaching infinity. That is the meaning of open circuit. So since this point is open circuited, at this point that is become air gap. The resistance offered by the air is what? Infinity. That is ideal. Resistance is infinity. So the value of current in the open circuit always 0. Finally, since this voltmeter also not consuming the current and the open circuit also not going to consume any current, then what is the current supplied by the source? Tell me now. If you apply KCL at this point, this is also consuming 0, this is also consuming 0, so the incoming current also must be 0 ampere. In open circuit, current will not flow. I hope you all know this logic. So the current flow through the entire circuit become 0 ampere. Okay sir, that is the next conclusion. Then what will happen? Now what my doubt is, can you please tell me what is the voltage drop across the 20 ohm resistor, 30 ohm resistor and 10 ohm resistor? So since current through the entire circuit is 0, if you calculate the voltage drop according to Ohm's law, V is equal to I into R. Since the value of current is 0 ampere, so what will you do? You will substitute 0 ampere into 20 ohm, 0 ampere into 30 ohm, 0 ampere into 10 ohm. So the voltage drop across the 20 ohm resistor will become 0 voltage. Voltage drop across the 30 ohm resistor will become 0 voltage. Voltage drop across the 10 ohm resistor will become 0 voltage. But what is the applied voltage here? The applied voltage is 230. Then where this voltage has gone? Since in our given circuit we have three loads now, 20 ohm, 30 ohm, 10 ohm resistors. They are not dropping any voltage now. Then where this voltage is gone? Then this voltage will simply appear across the voltmeter. So the reading of the voltmeter is 230 voltage. Because there is no any other place to drop this voltage. Voltmeter is the only person will going to consume this whole voltage. Okay, I hope now you all have understand this. Nothing is there. Okay, na? Fine, sir. So what is the correct answer? The reading of the voltmeter is 230 voltage. I know it's a chilly question, but what can I do? You all have to understand the fundamental basics in a proper way, such that when we are slowly increasing the toughness will not increase. But when we are moving on to the next chapter levels, automatically what will happen is you will face the question by combining all the fundamental basics like the concept of open circuit, short transformations, like source to voltage source to current source transformation, current source to voltage source transformation, star delta transformation, parallel combination, series combinations, under the basics of KCL, KVL, nodal, everything will be combined together in a single question. If you are not being very strong with the basics, then automatically you will get stuck. That's why I'm spending this many minutes in each and every question. It doesn't matter how long we are in single question. It's all matter is how you are understanding the basics fundamentally. Okay. Okay, sir. Chalo. Let us take the next simple question. The question is, let me draw the first circuit first. A 10 ohm resistor they had given here. Next, what happened is they have taken one more 10 ohm resistor here. Then here they connected one ohm resistor. Sorry, one more resistor. Then here they kept the supply voltage. So let us see what will happen. Uh, 1 minute. Yes, this is the given circuit. Then what they told is, as I told you, this is 10 ohm they told, and this is also 10 ohm resistor. And here they clearly kept 50 voltage, 50 battery. And here they kept this value is R. And they told that this circuit is simply consuming 2 ampere current. Now, you might have guessed what is the question. Find the value of R. That is the question. Figure out the value of R. Sir, how will you do that? Which method we can apply here? I told you, na, you can apply any method that you want. உங்களுக்கு மைண்ட்ல என்ன மெத்தட் தோணுதோ அந்த மெத்தட் அப்ளை பண்ணுங்க. Because we are not starting from the beginning. I know all of you are already aware of basics. So you can apply any method that you want. See, first of all, இந்த ரெசிஸ்டரோட வேல்யூ தெரியணும் அப்படின்னா according to Ohm's law, R equal to V by I. That's all. அப்ப இந்த ரெசிஸ்டர் வழியா போற கரண்டோட வேல்யூ நமக்கு தெரியணும். ஆல்ரெடி கொடுத்துட்டாங்க, that is 2 ampere. So the value of current is given as 2 ampere. But the voltage drop across the resistor is not given, VR. So let me keep, see, for resistor is a passive element, current entering point plus, leaving point is minus for the resistor. So voltage drop I can write VR like this. Okay, sir, fine. So simply what we can say is we have to identify the voltage drop across this resistor VR. Now we all know this terminal is treated as a ground terminal. So what is the voltage at this ground terminal? This is always 0 voltage. This is always 0 voltage. So now the question is, I hope you all have remember in our yesterday lecture I clearly told you what is the actual meaning of potential difference. I had given the definition for voltage. See, now this is the resistor VR. I just wanted to know the value of this VR. And எப்படி நம்ம find பண்ணுவோம்? If we want to know the voltage across this resistor, we have to find the potential difference between these two terminals. So இங்க நமக்கு என்ன தெரிஞ்சிருச்சு அப்படின்னா, in one terminal we are having 0 voltage. In another terminal we don't know what value that we are having. So let me keep that voltage is Vx. Now what is the value of VR? Sir, இங்க polarity வந்து clear indicate பண்ணிருக்கா? Polarity வந்து இங்க plus இங்க minus வந்திருக்கா? In our yesterday lecture, I clearly told you how we are following this polarity. I hope you are remembering this. அப்ப இங்க plus இங்க minus வந்திருந்தது அப்படின்னா by default it indicate that the value of Vx is greater than the value of 0. That's why here you are having plus and here you are having minus. So the value of Vr is nothing but the difference between these two terminal voltage. So the value of Vr equal to Vx minus 0, or we can say Vr simply equal to Vx. So what is the conclusion that we got here is the voltage drop across this Vr is simply nothing but the voltage available at this terminal. So what I was taking here, this voltage I am treating it as Vx. If here it is Vx, then here also same voltage will appear. Why? Why? Because here we don't have any drops. So same voltage will appear here Vx. Now what my question is, can we apply nodal here? We will apply. Shall we apply nodal here? Such that we will get the answer easily. How will you apply nodal? So let me apply nodal at Vx. Nodal for Vx. Nodal for Vx or at the node. Vx நம்ம apply பண்ணலாம். Step number 1. Nodal apply பண்ணும்போது நம்மளோட assumption என்ன அப்படின்னா selected node is the superior one. நம்ம எந்த node select பண்றோமோ அதுதான் superior and that will going to deliver the current for entire circuit. So let me call I1, I2, I3. நம்ம nodal apply பண்ணும்போது select பண்ண nodal வந்து கண்டிப்பா என்ன பண்ணணும், எல்லா பிரான்ச்சுக்கும் current வெளியில தான் போகணும். That is our assumption. So இப்போ நீங்க அந்த இடத்துல KCL apply பண்ணீங்க அப்படின்னா according to nodal there are three branches. Three branches will going to consume the current I1, I2, I3. First step நம்ம assumption apply பண்ணோம். Second step we have to apply KCL. How will you apply KCL now? According to Kirchhoff current law, in any selected node, the algebraic sum of incoming current equal to algebraic sum of outgoing current, or you can also interchange. Algebraic sum of outgoing current. I1 is going outside, I2 also going outside, I3 also going outside. Incoming current is always 0 while applying nodal. Only you will have outgoing currents. Now let us focus on the values of I1, I2, I3. See, the value of I1 is already given in the question, that is 2 ampere. What about the value of I2? I2 oda value namakku theriyadhu. Then how will you write the value of I2? See, if you observe, I2 is the current flow through the 10 ohm resistor. Let me take the 10 ohm resistor separately for your understanding once again. See, this is 10 ohm resistor. If you observe, one terminal of the 10 ohm resistor is having 0 voltage. Another terminal of the 10 ohm resistor is having the voltage Vx. Now, நம்ம current I2 இங்க இருந்தா போயிட்டு இருக்கா. இப்போ இந்த I2 ஓட வேல்யூ தெரியணும் அப்படின்னா how will you write? According to Ohm's law, இந்த லைன் வழியா போற கரண்ட் நமக்கு தெரியணும் அப்படின்னா இந்த லைன்ல இருக்க டோட்டல் வோல்டேஜ் டிராப் and divided by total resistance. இது தெரிஞ்சது அப்படின்னா இந்த லைன்ல போற கரண்ட் நம்ம கால்குலேட் பண்ணிடலாம். That is I2. Fine sir. Total resistance தெரியும் 10 ohm. இந்த total voltage எப்படி கால்குலேட் பண்ணுவீங்க? As I told you, see, anyway, current is going in this direction. Current entering point plus, leaving point is minus. இப்போ இந்த voltage drop across the resistor எப்படி நம்ம calculate பண்றது? This VR, let me call it as VR. Voltage drop across the resistor. இது எப்படி find பண்ணுவோம்? Potential difference between the terminals. So Vx minus 0 divided by 10. So the expression for I2 can be written as Vx minus 0 can be simply written as Vx divided by 10 plus. Similarly, I3 எப்படி எழுதலாம்? I3 அப்படிங்கிறது current flow through this 10 ohm resistor. எப்படி சார் எழுதுவீங்க? For your understanding, I am drawing that resistor separately. Now if you observe, I3 is going in this direction. Yes sir. Starting point la irukka terminal la voltage evlo irukku? Vx. Fine sir. Current entering point plus, leaving point is minus. See, நம்ம nodal apply பண்றது nodal வந்து ஒரு assumption தான் ஃபுல்லாவே. Current வந்து கம்ப்ளீட்டா வெளியில போகுது அப்படிங்கிறது நம்மளோட assumption. அந்த assumption வச்சு தான் நம்ம இந்த derivation சால்வ் பண்றோம். பட் நீங்க கரெக்ட் ஃபைனலா என்ன வந்துரும் அப்படின்னா நீங்க சால்வ் பண்ணி முடிக்கும் போது you will get the correct answer. That is the beauty of nodal. Okay, இப்போ இந்த டெர்மினல்ல Vx இருக்கு, ஆப்போசிட்ல இந்த டெர்மினல்ல வோல்டேஜ் எவ்வளவு இருக்கு? If you observe the question carefully, we have 50 voltage and polarity observe பண்ணீங்கன்னா top plate வந்து positive polarity, bottom plate வந்து negative polarity. So exact இந்த டெர்மினல்ல எந்த plate வந்து joined ஆகுது? This positive plate voltage will be reflected here. Negative plate value is considered as 0. இங்க மொத்தமா எவ்வளவு voltage இருக்கு? 50 voltage இருக்கு. 50 voltage பாசிட்டிவ்ல இருக்கா நெகட்டிவ்ல இருக்கா? இது +15 தானே கொடுத்திருக்காங்க. 50 voltage அப்படினாலே +50 தான். It means that 50 voltage we are considering across the positive plate. That's why it is considered as +50. அப்ப நெகட்டிவ் பிளேட்டுக்கு வேல்யூ நம்ம 0 கொடுத்துக்கலாம். இதே இடத்துல நீங்க -50 voltage கன்சிடர் பண்ணீங்கன்னா இதோட மீனிங் என்னன்னா பிளஸ் அண்ட் மைனஸ்ல 2 பிளேட்ஸ் இருந்ததுன்னா இந்த -50 voltage எங்க இருக்கும்? நெகட்டிவ் பிளேட்ல இருக்கும். அப்ப பாசிட்டிவ் பிளேட்டோட வோல்டேஜ் வந்து 0வா கன்சிடர் பண்ணிக்கணும். That's all. That is the logic. So across the positive plate here we have 50 voltage now. அப்ப நம்ம என்ன கன்க்ளூஷன் கொடுக்கலாம்? இந்த டெர்மினல்ல 50 voltage இருக்கு. But anyway already according to nodal assumption current is going in this direction. Yes sir. அப்ப இந்த ரெசிஸ்டர் 10 ohm ரெசிஸ்டர்ல இருக்க டிராப் எப்படி கால்குலேட் பண்ணுவீங்க? சார் நம்ம ஹையர் வோல்டேஜ்ல இருந்து லோயர் வோல்டேஜ் செப்பரேட் பண்ணோம். எப்படி இதை கண்டுபிடிப்பீங்க? நமக்கு தான் தெரியுது இல்ல, கரண்ட் வந்து இந்த டைரக்ஷன்ல தானே போயிட்டு இருக்கு. அப்ப அக்கார்டிங் டு அவர் அசம்ப்ஷன் தி வேல்யூ ஆஃப் Vx இஸ் கிரேட்டர் தென் 50. அது எப்படி எழுதுவீங்க? Vx minus 50 divided by 10 equal to 0. I'm strongly registering the method of nodal because nodal is the crucial part. It is very important. It will create beautiful curiosity when you are solving problems in analog electronics. See, let me tell you, 80% of the analog electronics questions can be simply solved with the help of nodal plus KCL. It is true. You might have gone through these lectures. Anyway, while entering into analog electronics, I will prove that. Don't worry. Now your task is, see that finally we got the value of, if in the expression la yaar mattum dhaan irukka, the one and only unknown is Vx. Can you please solve this? Yes, this is very simple. If I reduce this, Vx plus Vx will become 2Vx. Denominator வந்து சேமா தான் இருக்கு. அப்ப நம்ம டைரக்டா நியூமரேட்டரை ஆட் பண்ணிக்கலாம். So 2Vx minus 50 divided by 10 equal to, if you pass this 2 to the right hand side, it will become minus 2. இப்போ என்ன வரும்? 2Vx minus 50 equal to minus 20. From this I can say 2Vx equal to minus 50 right side போனா plus 50. Plus 50 minus 20 will become 30 voltage. From this the value of Vx will become 15 voltage. So we got the answer. And we also know what we know. The value of Vr and the value of Vx both are equal. Do you remember what we are doing in this question? We are trying to estimate the value of this resistor R. அந்த வேல்யூ நம்ம கால்குலேட் பண்ணோம்னா அதுல வோல்டேஜ் டிராப் எவ்வளவு இருக்குன்னு நமக்கு தெரியணும். அதுதான் இப்ப நம்ம கால்குலேட் பண்ணிருக்கோம். Since Vr Vx both are equal, so we got the value of Vr as 15 voltage. So what is the value of resistor R? We know the value of R equal to voltage drop across the resistor is 15 and the current flow through the resistor is 2. 15 by 2 will become 7.5 ohm. So what is the correct answer? 7.5 ohm is the correct answer for this question. Chalo. I hope you all got the basic idea. Okay. Now I will give some homework question. What you are supposed to do is take the same circuit, but I'm going to do some changes. Take the same circuit, but I'm going to do some changes. Okay. So I'm just closing this. Take same voltage also. I'm not going to change anything. So let me keep same 50 voltage here. Okay, sir. No changes here. And here what I'm going to do is, let me connect to 6 ohm. Here I'm connecting 3 ohm. Okay. And let me keep this value is R. Let us take 4 ampere. Now I hope you understand what I am asking. Now my question is, what is the value of R? This is homework question. Sir, please try it by yourself. Don't try to get the answer by with the help of someone else. Okay? You have to bring this answer by yourself. So this is all for this lecture. Remaining things we will see in the